In the United States, the year each coin was minted is printed on the coin. To find the age of a coin, simply subtract the current year from the year printed on the coin. The ages of circulating pennies are right skewed. Most circulating pennies were minted relatively recently, and extremely old pennies are rare. Assume the ages of circulating pennies have a mean of 12.2 years and a standard deviation of 9.9 years. Based on the information given, can we determine the probability that a randomly selected penny is over 10 years old? So I'm going to go back and read through what we have. So let's mark our important information here. So we have the ages of circulating pennies are right skewed, and they have a mean of 12.2 years and a standard deviation of 9.9 years. So up until this point, we only know how to work with things that are normally distributed. And we don't have a sample size or anything like that. So since they're right skewed, we cannot work with this. So let's box here. So no, we cannot determine the probability because the population of the ages of circulating pennies is not normally distributed. So we need two things to happen. Either the population needs to be normally distributed, or since we're working with sampling distributions, either the sample size needs to be larger than 30 in this case with sample means. So the next question asks, what is the probability that a random sample of 40 circulating pennies has a mean less than 10 years? So in this case, we have a sample of 40. So our sample size is larger than 30, so we're good. So remember that if the sample size is larger than 30, then we're okay, because the sampling distribution has a normal shape. So we need to write down our mean of our sampling distribution to start out with. Our mean is the same as the population mean, which is 12.2. And our standard deviation of the sampling distribution of the sample mean is sigma over the square root of n. So in this case, 9.9 over the square root of 40. And this doesn't come out nicely, so I'm just going to leave that. And you want to use that whole thing, or at least 6 decimal places, I think, will normally get you the right answer there when you're working with MyMathLab, or MyStatLab, sorry. So we want to know that it has a mean less than 10 years. So let's draw out a picture here. Our curve, we're working with x bar. So our mean here is 12.2. And let's see roughly what our standard deviation is there. 40. So this is roughly about 1.565. So if I do 10, it's just over here somewhere. We're going to know mean less than that. So we're looking at this region over here. So we're looking for the probability that x bar is less than 10. So we're going to do normal CDF negative 1E99, comma 10, and the mean of our sampling distribution. 2 there. And then we're going to do 9.9 divided by the square root of 40. So you can just go ahead and type that in there. So you can see this looks very similar to working with the applications of normal distribution, just the small difference there, the standard deviation. So second vars 2, -1 second E99, comma 10, comma 12.2, comma 9.9 divided by second, and this x squared button will give us the square root, 40, close our parenthesis to get what's under the square root, and then close it for normal CDF, and then enter. We get approximately 0.0799 there. So the next one we want to know, so be careful here, we're going to change up the sample size, but we still have a random sample of 40, so our sample size is larger than 30, so we're still good. We want to know a mean greater than 10 years. So again, you can use the complement, but let's write this one out. So we would do normal CDF, and then we're going to do 10, comma 1E99, our mean of 12.2, and then our standard deviation of the population divided by the square root of our sample size, since we're working with sampling distribution. Okay, so I'm going to do 1 minus the answer, so now that's the complement, and then let's actually do it using the normal CDF. So normal CDF 10, comma 1E99, comma 12.2, comma 9.9 divided by the square root of 40, close parenthesis to end the square root, close parenthesis to end normal CDF, and enter. So 0.9201. So you'll notice here we get the same answer either way. So if you have a calculator that has the menu, same thing. So second var's normal CDF. So you type in your lower, which is 10, press the down arrow, type in your upper, 1E99, go down to mu, and you would type in 12.2, go down to sigma, and you would type in 9.9 divided by the square root of 40, close your parenthesis, go down to paste, press enter, and then press enter again. So last part here, we want to know, so again we're looking at a random sample of 40 and greater than 15 years. So we want to know the probability that X bar is greater than 15. So we're going to do normal CDF 15, comma 1E99, and then our mean, and then our standard deviation of the sampling distribution. And I basically have something like that already typed in, so I'm going to do second enter to go back to what I typed in, go in and type over the 10 and type 15 and press enter. So we get 0.0368, and then we want to know, would that be unusual? So yes, since the probability that X bar is greater than 15 is less than 0.05. Right?